So today, we're going to dive into something that's sitting right on the horizon, the battle between quantum computers and the blockchain. We're going to be looking at a project called UTON, which claims it's already built the shield for an attack that could, in theory, shatter our entire digital world. Let's jump right in.
Wow, that's a pretty heavy statement, right? And it gets straight to the point. The encryption that protects basically everything we do online, from our bank accounts to our blockchains, is built on math problems that are just way too hard for today's computers to solve. But quantum computers, they're a whole different animal. They're literally designed to crack these exact kinds of problems and with incredible speed. And look, this isn't some far-off sci-fi thing. It's the next huge leap in technology, and it comes with a serious, serious catch.
And you gotta understand, this goes way beyond just Bitcoin or your favorite crypto. Think bigger. The encryption that's guarding your files in the cloud, your online accounts, your company's most sensitive data, it all uses the same basic principles. The source material is blunt about it. It's all built on a type of math that a quantum computer could break, maybe even overnight. So yeah, that's the billion-dollar question, isn't it? If the digital locks we use for literally everything are about to become totally useless, what do we replace them with? How do we build a new foundation that's not just safe for today, but safe for the quantum age we're heading straight into?
And this leads us to what folks in the security world are calling the quantum countdown. The thing is, it's not really a question of if this will happen, it's a question of when. And getting ready for it isn't something you can just do at the last second.
Okay, so let's unpack that a little. The encryption we use right now, things like RSA or elliptic curve, it all depends on how hard it is to factor enormous numbers. I mean, your laptop right now, it would take billions of years to crack a single key. But a powerful quantum computer, we could be talking minutes or hours. That's the vulnerability right there. And that's what makes this so real, so personal. We're talking about Bitcoin and Ethereum, the two biggest blockchain ecosystems on the planet, becoming completely insecure. We're talking about your personal files stored online. We're talking about the accounts you log into every single day. The entire digital world we've built is standing on a foundation that's starting to look pretty shaky. Okay, so that's the scary part. A bit unsettling, right? But let's flip the script from the problem to the solution. This is where UTON steps into the picture, positioning itself not as a quick fix for the old system, but as a totally new kind of digital vault. And I gotta say, I love this analogy from the source material. While pretty much everyone else is trying to figure out how to reinforce a lock they know can be picked, UTON is saying they've already gone ahead and installed a completely new one. So what they're saying is, this isn't some promise for an update down the road or a plan on a whiteboard. They're claiming the solution is built and working right now, designed from the ground up to be totally immune to that quantum threat. So you're probably asking, how does it actually work? Like, what's under the hood of this new lock? Well, UTON's defense is built like a 3-layer shield, and each layer is designed to protect a supercritical part of the blockchain. All right, layer 1. This is all about you. Your digital wallet is protected by your private key. Simple as that. If that key gets cracked, poof, your funds are gone. UTON uses a whole new type of cryptography, one that's based on math problems that even quantum computers should find incredibly difficult to solve. So this first layer is all about securing your personal assets right at the source. Okay, now for the second layer, which builds right on top of that. It's not enough to just protect individual wallets if the network itself can be attacked. You know, a blockchain is basically a giant network of thousands of computers, or nodes, all talking to each other all the time. UPON secures the communication lines between them, making sure no quantum attacker can listen in or mess with the data as it's flying around the network. And this brings us to the third and final layer. And honestly, this might be the most important one. Every time a new block of transactions gets added to the chain, it's sealed with a digital signature. That's the magic trick that makes a blockchain, well, a blockchain. It can't be changed. UTON uses quantum-proof signatures, which means once a block is sealed, it's sealed forever. Not even a quantum computer could go back in time and fake a signature to change the past. Okay, so the security sounds impressive, right? A 3-layer vault. But here's the million-dollar question for any blockchain. Is it actually usable? Can it perform? Because a fortress is pretty useless if it's too slow for anyone to actually get in and out. So let's look at the numbers. And boom. Here's the headline number, 100,000 transactions per second. Just to give you some context, that's fast enough to compete with huge global payment networks like Visa. So this isn't just about security. According to UConn, this is a network that's built for huge mainstream adoption.
And this really puts it all into perspective. You look at Ethereum, one of the biggest and most used blockchains out there, handling about 15 transactions per second. UTON is just in a completely different league. And check out the fees. We're talking pennies compared to the often sky-high and unpredictable gas fees on Ethereum. That 1-2 punch of high speed and low cost is aimed squarely at solving two of the biggest problems holding back blockchain today.
Now, this next part, this is absolutely huge for developers. Being Ethereum compatible means that all the thousands of apps, developers, and projects that are already on Ethereum can just move over to UTON without having to rebuild everything from the ground up. It's kind of like building a brand new quantum-safe superhighway right next to the old, crowded road and just adding a really easy on-ramp.
So, okay, we've got the security, we've got the speed, but is it actually ready for the real world with all its regulations and economic systems? And this is where things get really interesting. Governments and regulators are starting to wake up to this quantum threat. They're starting to write laws that say critical systems, things like financial networks and national security databases, have to be upgraded to quantum-safe tech. What UTON is saying is, they're not just ready for the future, they're already compliant with the laws that are being written for that future. And of course, at the heart of it all is the native token, UTN. It's got some really clear uses. You use it to pay for those super low transaction fees. You can also stake it, which means locking it up to help keep the network secure. And for doing that, you earn rewards as more people use the network and it grows. It gives everyone a real reason to participate in keeping the network healthy. And that brings us to this final quote, which really sums it all up. After all the nitty-gritty details about keys and signatures and transaction speeds, it all boils down to one simple thing: peace of mind. That storm they're talking about, that's the quantum revolution. And UTON is basically selling itself as the bunker that's already built and waiting for you. So the big takeaway here is all about being ready today. Their message is pretty straightforward. This isn't some idea for the future. They're saying the tools you need to build, to invest, and to transact on a platform that's safe from quantum computers are here right now. And really, that's the big question I want to leave you with. As more and more of our lives, our money, our identity moves online, protecting that digital world becomes everything. This coming wave of quantum computing really forces us to ask if sticking with the old ways is a risk we can afford to take. So, is making our digital world future-proof just a nice idea, or is it something we absolutely have to do?